Stuck on CNA labs? Tired of scattered tutorials? This full course covers every exam topic with real lab configs. Grab your free lab in the description. Ready to pass CNA and boost your career? Start now!
Hello everyone. In this lesson, we'll learn about the OSI 7-layer network model. After completing this lesson, you should understand the OSI 7-layer model in data communication, how it is layered, and grasp how, during data communication, data packets are encapsulated, and how the receiving end decapsulates the data packets. The key focus of this lesson is the OSI 7-layer reference model. This is arguably the first major hurdle in the CCNA curriculum. You should pay close attention to this during the class. First, let's understand what the OSI model is. OSI stands for Open Systems Interconnection Reference Model. It was proposed by the International Organization for Standardization, ISO. This raises a question. Why do we need an OSI reference model? It's like this. In the beginning, everyone manufactured computers and produced PCs. Then, when they tried to communicate, each had their own standards. I used my standard. You used yours. It's like our two countries using different languages to have a conversation. It's a complete mismatch. Nobody could understand. So, ISO stepped in and said, to facilitate communication, we need a standard communication model. Thus, the OSI reference model was proposed. This was introduced by ISO. It provides a reference model. All vendors and software developers for various systems should follow the OSI model to develop their hardware or software to ensure communication with other devices. If you don't follow the OSI reference model in your design, everyone else designs to that standard. They won't understand your content. Your devices won't be able to interact with others. So, the OSI reference model is a very important guiding standard. Basically, all vendors need to design according to this standard. The main purpose is to make it easier for our devices to communicate with each other. Now let's take a look at the OSI 7-layer. Why is it called 7? Because it breaks down the data communication process from the top layer, closest to humans, down to the layer closest to hardware devices. It's divided into 7 layers in total. These 7 layers are the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. There are quite a lot of layers. Each layer has its own specific tasks to and its own significance. Of course, between each layer, between upper and lower, there is a certain connection relationship. It's not that they are completely independent. Each layer does its own job. But they also need to cooperate with each other to complete the entire data communication process. This is the basic definition of the OSI 7-layer model. Okay. Now, these 7 layers, they are too complex for us to. Generally speaking, we can divide these 7 into 2 main categories. We can divide them into 2 levels. The first level is the level related to us users. We call it the user level. It mainly includes the application layer, presentation layer, and session. These layers are mainly for software development and system operations. These are tasks that those colleagues might be involved in. As network engineers, we actually care more about the bottom 4 layers, because this is where data communication happens from one end to the other. How to focus on communication. So as network engineers, we need to master and understand each of its layers. These 4 layers below, what each layer contains, and the contents of each layer. We will specifically expand on them for you later. Here, let's first get a general idea. So the top, closest to us users, or the human layer, is still our application layer. Inside the it is mainly applications, and also corresponding So note, the applications referred to here are actually not the software you see on your computers. That we call software. right? Sometimes also called but they are not really. What we refer to here as programs in the programs in the application layer. Refer to what? They refer to our application protocols. For example, when we use a browser. Right? Like using this Chrome. Right? Google's browser. You open a web page. For example, right? Note here. The application protocol we use. The application is actually not Google's Chrome browser. But what is it? It is our HTTP. Or HTTPS. These two protocols are not the software. You must be clear about this distinction here. Be clear about this distinction. So, at this point, in our application, it performs some operations. It might want to send some types of data. Or receive some types of data. This data is then handed down to our presentation layer, which performs formatting on this data. Some conversions, or encryption and decryption, or compression and decompression operations. These are things done in the presentation layer. It takes the data handed down from the application layer, processes, converts its format, encrypts and decrypts it, compresses and decompresses it. Then this data continues down for further transmission to our session layer. In the session layer here, it needs to handle different applications and separate the data. Separate the data. Essentially, different protocols. And also, between you and different users. When communicating data, it must all be isolated. Without isolation, it could lead to information leaks, causing some security issues. It's just like using WeChat or QQ to send messages to classmates. If isolation is not properly done, other classmates might also see the message. Or, right, other operations could potentially happen. That would be inappropriate. So the session layer mainly isolates different applications and different users. It handles the process of separating their data. It keeps them isolated. In that case, this data content is basically processed. The next step is how to transmit it. From the user's perspective, this part is all finished. The next step is how to deliver this packet to the target device. Right? Okay, so let's look at the network-related considerations below. The transport layer. The transport layer. It mainly provides end-to-end message transmission and error control. Within the transport layer, it's mainly about our data packets. Right? How do they go from my computer to, say, Baidu server? During this process, every application corresponds to a window in our transport layer. This window, we call it a port number. Called a port number. The application we need to access and the data we need to transmit must correspond to that application's port number. It's like, what if, when we go to the cafe, to eat? Right, to get food in the cafe, each dish corresponds to a window. The dish you want, you must go to that corresponding window. You can't go to the wrong one. If you go to the wrong window, you might not get the dish you want. Understand? When the transport layer mainly has a corresponding relationship with each application protocol in the application layer. There is a corresponding relationship. Now, this data. During the transmission process, there might be some errors. For example, when the network quality is poor. Right? These packets might, during transmission, get lost. Or, these packets might, get corrupted. So in this process, there will be some error control. And also, your current network quality is very good. Right? The quality is, then the amount of data to be transmitted might be increased. This is regulated in the transport layer. To control the quality of our transmission. After this is determined, the next step, we need to find where the other device is. Find where the other device is. This is our network layer. The network layer, its main role is to take the devices above, the data content processed above, and package it. So inside the network layer, we call this a packet, or a data packet. Package, right? Here we call it a package. That is a data packet. The main purpose of the network layer is to take this data packet from your end, right? The source end, the device sending this data packet, and deliver it to the receiving end. We call it the destination end, right? Send the data packet from the source to the destination. In this process, for example, from my computer to Baidu's server, it might pass through a bunch of devices in between, right? So during this process, it might have many choices. Like what? The routing part, right? After my data packet goes out to the telecom carrier, then what about between the carrier and Baidu server? There could be many link connections. So which path is the best one? Well, this is what we call route selection. It's actually just like driving on the road, right? It's just like using a GPS. You want to reach a specific, right? Say, for example, my destination is Baidu's server, right? So, if you're driving with a GPS, say you want to go to you want to go to at this point, the park is our destination, right? What is the source? It's our starting point, right? And this is when you start navigating, you'll see many routes appear. Many. So at this time, you need to make a choice. Which route is more suitable? Right? For example, this road is relatively straight. And then, the road is also quite right, with no bumps even though it might be a slightly longer way around. Right? But it reaches the destination point. This time might be relatively short. Or maybe, a certain, has fewer traffic lights. Or maybe, a certain, has no traffic jams. Has an elevator, right? And so on. Anyway, there are many factors to consider. Now in this network domain here, it's the same. It needs to take the data packets. This data we just packaged up. And send them from your computer to the target device. There will be many paths in between. So at this point, some path selection control is needed. How is this selection made? Well, is handled by something you will need to focus on learning later, called a routing protocol. It will make the decision. So, it will be used to make the decision. Okay. So, this way, after the selection is complete, after the selection, we know how this data packet will exit. It's like getting in the car and turning on the navigation. Right. You then know how to, however, in the process of data communication, it's not quite that simple. After you start driving forward, right? This data packet then enters the next layer we need to process, the data link layer. What does the data link layer? It takes the data packet handed down from above. Right? What does it encapsulate it into? We call it a data frame. Encapsulate it into a data frame. Then, what does it need to provide? Node-to-node transmission and error control. What is node-to-node? For example, my computer is connected to my home router. So node-to-node refers to the segment from my computer to the router. This segment is handled by the data link layer. It's like the nearest. How to get to the next intersection? How to get to the nearest intersection? Okay, so there is a question here. Why do we need this data link layer? The main function of the data link layer is actually to perform error detection. Because below it is the physical layer. This data packet needs to be converted into electrical, radio, or fiber optic signals. Right. Through fiber sent to another device. The physical medium in between. We covered this in a previous lesson, right? The physical medium is very likely to encounter interference during transmission. Our signal can be subject to interference, right? Potential interference at the physical layer. How do we mitigate that? So we need a layer responsible for error detection. The data link layer performs error detection when your data travels through the physical medium below to the peer node. Because our data signal is definitely transmitted bit by bit, right? It doesn't mean you'd plug into Baidu's server to access it, right? It goes through your home router. Then the router to the ONT, then the ONT to the ISP's access OLT. Then the OLT to their access switch. It goes through a whole bunch, right? So for every segment, each segment performs error control to prevent packets from being corrupted. To prevent our upper layer packets from getting corrupted during transmission, right? Therefore, at the data link layer, it performs error control during signal transmission between each node. So it's more specific. Compared to the network layer, it's more down to earth. It handles hop by hop or node to node transmission. This transmission process is controlled by the data link layer. So these are the 7 layers of the OSI reference model. 7. Let's look further down. These 7 layers, based on the earlier user and network perspective, are divided into, right, relatively speaking. There is actually another, simpler model. For example, our DoD model. The DoD model, well, divides the data communication process into 4 layers. Divided in, the top 3 layers are collectively called the application layer. The transport layer is still, the network layer is called the internet layer. There's not much real change. Right, then the bottom 2 layers, the data link layer and physical layer, are merged into the network access layer. Network, because it mainly handles signal transmission for device-to-device communication. Right? Oh, so this mapping relationship, you just need a general understanding of it. Because his classification method, anyway, has many types. Here are just the more common ones. The more mainstream classification methods. I'm telling you all this. Now let's delve into the study of each layer. First is the top application layer. It is mainly for our software. Like our, browsers, right, our chat software. Video playbacks, right, it provides an interface. And then, allows these programs to use our network. So at the application layer, the most important things are our application protocols. Mostly application, it opens up to different software, right, and then supports them in accessing our network. The most common ones, the ones we see quite often, are these few types. For example, HTTP, HTTPS. The are for our web access. When you visit websites through a browser, it's through these 2 protocols. Then DNS. DNS is, when you access something, you type in baidu.com. During the process of typing baidu.com, it needs to be converted into a logical address for the device. Something we call an IP address. It needs to translate, because IP addresses are hard to remember. They are very hard to memorize. You can remember 1 or 2. But if right, DNS here, can also turn these IP addresses into names that are easier to remember. For example, right, 360QQ. These are very easy to remember. You can remember, right, so one function of D is to map IP addresses to names. It creates a mapping relationship. These are the most common ones in our daily lives. Then the following ones. Many of them are hardly used nowadays. Right, for example, FTP. Now, when people download files or something, they rarely use FTP anymore. They basically use software like Thunder on websites to download directly. Right? In the early days of the internet, when we downloaded or uploaded files, there were dedicated FTP sites. Using the FTP we uploaded and downloaded files. It was specifically for file transfer. Its name is File Transfer Protocol. Now it is rarely used. It might still be used in system operations. It's basically rarely used. Then the following SMTP and POP3. These 2 are both related to email. Both of these are related to email. Then Telnet. Telnet is a protocol for network management. A remote login protocol. These protocols are relatively standard and quite common. Of course, there are many others. Application layer protocols are vast. Impossible to list them all. Here we can only list some commonly used protocols as an example for you. So users, through operating software. By operating software, invoke these interfaces exposed by our applications. These exposed and then use our network services. Right. This process generates some data. It generates some data. And this data is passed down to our presentation layer. Let's continue down. When data reaches the presentation layer, some operations are needed. For example, encoding and decoding data, or encryption, decryption, compression, and decompression. For instance, when I visit Baidu, there might be text, there might be images, there might be music, there might be videos, a whole bunch of this content. Right? And this content needs to be encoded. It needs to be there are different encoding formats. Right? Like, for example, our MP3, WMA, AC, what lossless, lossy, various compression formats. Right? And images, various right? So these formats all have their own encoding. So when our browser receives this data, when it receives this data, it must be able to display these images for you. Right? It must be able to this process involves encoding and decoding. A process, then, of course, I need to encrypt it. Right? I need to encrypt it. It cannot be directly, transmitted openly and casually over the internet. Right? For example, when you enter your account and password. Right? This content needs encryption and decryption, So when we input it, it needs to be encrypted at the presentation layer. Right? And Baidu's server side probably needs to decrypt it. Right? This is all done in the presentation layer, So, first, they need compression and decompression, because the content might be too large. Right? The content might be too large, so I need to perform basic compression on it. Compress the originally large content, to facilitate to improve our transmission efficiency, This is done in our presentation layer, So from the application layer, right? The browser software calls the application protocol, to take the data information, to take the data, after passing it to it performs encoding, decoding, encryption, decryption, compression, decompression, and our session layer below. Handed down to our session layer below. After the session layer receives this information, based on our session connections, it isolates different data. To isolate different data. For example, in your software, you can open multiple right? Open several, then each website is a session. So, the signals between these different websites, the transmission of this, are all independent of each other, isolated from each other. Otherwise, right, say you visit Baidu in QQ. Right, then the content from the QQ bleed into Baidu, right, that would not work. It must be isolated separately. Placed in an independent space. So, a function of the session layer here is to categorize this corresponding information into separate groups to manage it independently. This makes it easier for us to schedule later. To coordinate this. So, in here, it involves a communication process. When a session we need to transmit data, right? So here, there are several transmission modes. Simplex, half-duplex, and full-duplex. This is a relatively simple concept. So, simplex means sending in one direction only. That is, at the same time. Not at the same time. It is always. Signal transmission can only occur in one direction. For this port of yours, the other side's port can only receive. This is called simplex mode. What is this similar to? The remote control at your home. Inside your remote control. This infrared light, right? It can only emit signals outward. Then your TV or air conditioner has an infrared receiving device on its side. Right? It can only receive our infrared signals. Right? This is what we call simplex. It can only ever send. Or only ever receive. That is simplex. What about half duplex? It can switch. Right now I send. And later I can receive. However, at the same time, while I am sending, while receiving, I cannot send. This is called half duplex mode. What about full duplex? It can send and receive simultaneously. That is more advanced, right? Basically, all of our current devices have interfaces that are all in full duplex mode. You basically never see half duplex. Or modes, right? Okay. This is the process of data being transmitted downwards. How communication is carried out. This is the session layer, up to this layer. After this layer is done, next comes our transport layer, which is the process of network transmission. So this data, after coming down from the session layer, it needs to have some operations performed on it. What operation? Segment the data packets. Segment the data packets. For example, if I want to download a movie or a song, or a picture, these files might be quite large. They might be. At this point, our network cannot transmit such a large piece of content. What to do then? Segment this content. Chop it into very small blocks. Chop it to pieces. And package them individually. Package each piece separately. Each packet is small, right? Once small, I can transmit them over the interface. So at the transport layer here, a very important point is segmenting the data packets. First, segment them. At the same time, at this stage, it also needs to solve a problem. Which specific application does it correspond to? What kind of application? For this, our transport layer here has a specific design. There is a mapping at the application layer. There will be a mapping with the application layer, like our HTTP. As we saw earlier with the application, you can see that there is some data following. A number, right? 80, 43 here, and so on. This is something that maps to the transport layer. We call it a port number. Called a port number. Every well-known protocol. Note that these are called well-known protocols. Globally, they are recognized protocols that we call them these well-known protocols. Each has its own unique port number. Each has its own port. We cannot use these port numbers arbitrarily. If you want to use them, you must apply to an international organization. Otherwise, others will think. If you use, say, port 43 to send data to someone, right? The receiver will assume HTTPS is used to process it. Right? Then when it's processed, these packets become inexplicable. Right? It simply cannot. So there is a one-to-one mapping here. Then, when these packets are sent, I now segment these data packets coming down from the upper layers. Right? After segment, you must also, after the receive, you need to reassemble, right? You need to reassemble them again. We also need to consider a reassembly issue. In our transport layer, for example, and one is TCP and the other is for TCP. When segmenting data, it will number the data pack. Okay, the first segment cut off is marked as, the second is marked as 2, and so all packets have their own sequence. Then, they are transmitted through the network below. After arriving at the destination, the peer receives these packets. Right, 1, 2, these packets are then reassembled in this, right, pieced back together. After it is restored to, the complete packet. As it was before, right? Then it is, passed up, and it's done. Okay. So here we need to this issue of segmentation and reassembly. And we must also consider connection control, flow control, and congestion. Okay. For example, our TCP, when communicating, must first create a communication channel. First create a communication channel. So there will be this connection-oriented, needing to control this connection. When to connect. When to disconnect, and also traffic flow, which involves a concept called sliding window. We will elaborate on all this later. We will explain it. Right now, the network port is relatively idle. Your network interface card is currently right? When there is not much going on. At that point, your traffic flow can be a bit heavier. Right? So you can increase the window size. If, on the other, the network card is currently busy, you can decrease the window size. This will reduce the traffic flow. There is also some error control. For instance, I was supposed to send 1, 2, but the receiver got 1, 2, 4, and 3 is missing. 3 is missing. The receiver can request a retransmission. We call this TCP retransmission. Performing a retransmission, right? In short, many operations occur here. Starting from the transport layer, I will elaborate on the subsequent content in detail later, because this is a key layer we network engineers must focus on and learn. For now, we just need a general impression of it. Okay. So these data packets coming down from the transport layer. Once handed off to our network layer. Here at the network, it will first encapsulate them, and then I need to process this packet. Need to find the other parties. Need to find the other party's logical address. Need to find the other party's logical address. So this logical address. Well, the most common one we call IP. Called IP, we also call it every device will have its own IP address. When we communicate with the other party, we do so through this IP address. So these contents need, well, the main purpose of our network layer is to take these data packets passed down from above, encapsulate them, okay, and then send them from the data source to the destination. Send them to during this process, route selection must occur. So, its typical representative device is our router. Router, right? Its main purpose is to perform packet path selection. To perform path selection for it. Maintaining the routing table and this is the primary role of a router. Of course, actually, currently. Like our switches, we should have mentioned layer 3 switches earlier. Right? Why do I call it a layer 3 switch? Layer 2 switch. So what does this layer refer to? Well, it refers to layers 2 and 3 in our OSI 7 layer model. The third layer of the OSI 7 layer network model is our network layer. The second layer is, right? So if we say it is a layer 3 switch, what does that refer to? It refers to having network layer functions. What are the functions at the network layer? It can perform route selection. It needs to maintain a routing table. It provides logical addressing. Right? These are all part of the network layer. That means this switch of ours has some of the functions of a router. This is the main point of a layer 3 switch. What about a layer 2? It operates at the layer below, the data link layer. It does not have route selection or routing table maintenance functions. So its functionality is relatively simpler. Right? So this is based on its functionality. A classification. So, a layer 3 switch versus a router. If you are just using them within an internal network, you won't really notice much difference. In many places, we have even phased out routers. They don't use routers at all anymore. Okay. The purpose of the network layer is to get a packet from my computer to Baidu's address. Baidu has its own IP address. I have my own IP, right? How does this process reach the other side? Which exit should I choose for the next step? Right? For example, my home has 2 broadband lines. Which broadband line should it go out from first? This is a process of selection. Right? For example, you have 2 paths, one takes the L, one takes the ring, so which one do you take? This is your own choice. Right? So how is this it requires our routing protocols to make the choice. These routing protocols are also a key focus of our CCNA course. This is also a key focus for network engineers in their future work. Okay. So, after these packets are assembled, they are handed down to our data link layer. Its purpose is to operate over an unreliable physical link. We say the physical link is unreliable. Right? It's easily subject to all kinds of interference. So, to work over an unreliable physical link and provide a service for as reliable data transmission as possible, it handles the process from one hop, which we call a node, moving inside, and then on to another node. During this process, it protects the data frames. This is the main function of the data link layer. So, it takes the data, these packets handed down from above, and encapsulates them into data frames. Then, it handles the physical addressing. What is physical addressing? Well, every single port on a switch on these devices has its own address. This is called a physical address. For example, the network layer also has an address. Right? That one we call because that address can change. It can change. So, this physical addressing refers to the address of a network card. We call it the MAC address. As for this address, although we can change it at the system level, actually, our network card, when it leaves this address is already burned onto the physical hardware device. Burned directly onto its chip. Therefore, this physical addressing means every network card is different. Everyone is different. So, in this case, I can identify these data packets and the data frames they form. Right? These data frames are sent from my to the remote both sides have an ID. Right? Both have an address. This makes identification easier. Then, operation control, and access control, these are all they all serve to better transmit our data. to transmit more our data. The representative is our switch. Whether a layer 2 or layer 3 switch, it has data link layer functions. Note, it's not that a layer 3 device lacks layer 2 or layer 1 functions. If you are a higher layer, like layer 3, you must have layer 1 and 2. Because the lower the layer, the more fundamental it is. It's like building a, right? Can you say, I only want the third floor? And skip the first? Can that be built? It cannot be built. To build a third, you must build the first and second floors first. So, a layer 3 switch also has complete layer 2 data link layer functions. A layer 2 switch has layer 1 and 2 functions. It has layer 1 and 2 functions. A layer 3 switch has layer 1, 2. Some ask, is there a layer 4 switch? Generally speaking, no. We generally say, because higher up, the functions are the same. The functions are real, or we call a layer 3 switch a multi-layer switch most of the time. Generally speaking, we commonly call it a layer 3 switch. Calling it a multi-layer switch is also correct. Some people call it that. A primary function of a switch is right here at the data link layer. To perform our data switching. To perform data switching, this process does not require looking up IP addresses. It doesn't need the support of IP addresses from the network layer. The switch can directly enable communication between devices. Of course, if your devices need to communicate across networks, requiring network layer communication, you must use a layer 3 device. For example, a layer 3 switch, a router, or a firewall. You need at least layer 3 functionality. Then data frames are passed down to the physical layer. The physical layer takes these data frames and encodes them into our bit stream. Encodes them into a bit stream. When this data comes down, what is a bit stream? It's just a signal, right? Data of ones and it becomes a bit stream. After becoming it travels through our physical media. The transmission media of the physical layer. Right? For example, through optical through radio wave, right? It sends these signals out. Sends them out, right? For instance, or voltages to represent 0 and 1. Right? To represent them differently. Then it can be transmitted to. These signals can then be transmitted to the receiving NIC. Once the receiving, it identifies the electrical signals. Right? And converts them back into a bit stream. The bit stream is then passed up to the data link layer to be reassembled into data frames. Data frames, right? Then it moves up the layers. After becoming data frames, right? They are reassembled back into packets, reaching the network, right? After reaching the network layer, it corresponds to our transport layer. Corresponds to the transport layer. Then the data is given to the session layer. Reassembly might be needed here. Right? Passed to our session. The session layer maps to each different application. Because they are in, right? Session control happens here. Then going further up, we reach the presentation layer. To decode these data packets. To decrypt them, and to decompress, then they can be given to our application. Given to our application. Decoded by it, and then presented on our computer. And it can be displayed. This is the complete process of data communication. This covers the specific content of the OSI 7-layer model. The basic concept of each layer. Now, we need to clarify one point here. The OSI 7-layer model takes a relatively complex process and divides it into finer levels, 5. Right? 5 levels, 7 layers. And each layer has its own function. Has its own function. And between each layer, layers are independent of each other, yet also rely on each other. For example, your network layer, right? Depends on your data link layer and your transport layer to function. It cannot work independently, right? Just like building a, right? It cannot just float there alone. Here, the upper layers are our application layer, presentation layer, session layer, these things. Upper layers depend on lower layers. Upper layers depend on lower layers. Just like building a house, right? I've emphasized this several times. To build a third floor, you must rely on the second floor. And to have a second, you must have a first, right? The first floor, right? This is how lower layers provide services to upper layers. Just like our physical layer provides services for our data link layer. The data link layer receives some services. It takes the signal you get, I transmit it out, right? Converting it into optical signal or radio waves and sends them out. Then the data link layer provides services for our network layer. If you want to travel, right? I want to go to. For instance, I want to go to the, or I want to go to the, right? If you want to go that, you have to go step by step. You cannot just fly, right? In some novels, they just teleport directly. Right? In real life, it's impossible to just teleport, it has to transmit segment by segment. Travel segment by segment. So, the data link layer must handle getting your data to the next intersection. Right? How to proceed at, and then continue forward from there. Right? Turning left or falls under the net, just path select, right? After selecting to the next it must guarantee the security of each segment. Similarly, the network layer. The lower layer serves the upper layer. The upper layer depends on the lower layer. Okay. This is the content of each layer. You must memorize these 7 layers. Especially the bottom 4 layers. Especially the bottom. As a network you absolutely must remember them. The transport layer provides reliable end-to-end segment transmission and flow control. The network layer delivers packets from source to destination. Delivers them to providing network interconnection. Then, our data link layer encapsulates packets into frames, providing node-to-node transmission. Guaranteeing this, then the physical layer, over physical media. Transmits our bit information. The 0 and 1 information. Right? It must provide some standards. For example, for your network cable. Right? How many wires and the wire gauge, for example, what should its wire, right? What material is the copper conductor? The outer plastic jacket. Right? What material, all these have clear specifications. Including the right? The copper pins what material should they use? And the plastic housing material too. Same for fiber, they all have very strict standard requirements. These are all in the national standards. For example, you can search online. Making a network, right? It's national what are the standards? You can find all this online. From these standards, you can also learn, for example, you can learn why twisted pairs are twisted. Right? And why the twist pitch differs between pairs. Right? And why use oxygen-free copper? Right? Also, for example, your RJ4, the copper pins on it. Right? Why use phosphor? There are many details involved here. Don't underestimate these things. They are actually all around us in daily life. Networking actually has great depth. It has great depth. As a network if you haven't mastered these contents, it's not a big problem actually. You can still manage our network devices. But if you can grasp them more specifically, then when you start working in the future, you might get some better opportunities. Okay. So this means the process of data sending and receiving. The sending process is called data encapsulation. The receiving is called data de-encapsulation. The encapsulation process starts from the right? At the application layer. At the application, our data packet, which we call data, right? Data is handed to at the transport layer. It adds a transport layer header. This header marks the corresponding source port and destination port. We call these right? We call these port numbers. These port numbers are used for data segmentation. Right? When data comes down, the transport layer must first segment the data packet. It segments the data. The content is after segmentation, it adds the header. Right? The header marks the corresponding source and destination ports. It marks the corresponding application protocol. It marks the port numbers actually correspond to right? Then this data is passed to the network layer. The network layer receives this content. It treats everything from the transport layer as its data portion. We call this the data. We also call it the payload. The payload. Or the data portion. Either is fine. Then put the corresponding IP in front. Put the corresponding IP. Source IP, destination IP, and the corresponding protocol number. For example, we transmit via TCP. The protocol used at the transport layer, or source IP, use UDP, right? You need to mark it to make it easier for us later. For the receiver to parse the following content. So we need source IP, destination IP, and protocol number here. Of course. The header content is very complex. Like the transport layer header and network layer header. These contents, we will cover them in detail in later courses. Here, source is your own IP address. Destination is the address of the device you want to access. Fill it in here. It's like going to a park. Right. Source is your home. Destination is, you write it down. Then this content goes to the data link layer. Goes to the data link layer assembles it into a data frame. Right. Encapsulates it into a data frame. Then put source MAC and destination MAC in front. Source MAC is your own computer's MAC address. Destination MAC is the device at the other end of your network cable. What is its MAC address? Okay. Write it here. Of course, for example, how do you know the MAC address of the other end? And the IP address of the destination you want to access? Right. These IP addresses and so on. These are all things we will learn later. Put on all these required marks. Then it can go to the physical layer. Right. The physical layer converts it into a bit stream here. After converting it into a bit stream, through various signals, through the media in between, to transmit it to the peer device. Right. After the peer device receives it, it needs to decapsulate the data. Perform a decapsulation on the data. First receives the electrical signal through the physical media, or other types of, right. After receiving, converts it into a bit stream of zeros and ones. Right. Then according to the specification, converts it into a data frame at the data link layer. Converts it into then looks at its header. The header contains the source MAC address and destination MAC address. Then compare it with our own MAC address. To check if it matches its own MAC address. Is this destination MAC address my own MAC address? If it is, then it continues. If it is not, it means this data packet. This data frame is actually not intended for me. Right. There is a destination MAC address in it. Compare it with your own MAC address. If it is not, then drop the data, drop it. If it is, then continue to, right. Strip this header off. Strip the data link layer header off. And hand it up to the network layer strips its header off. After receiving this, look at the header in the network layer. The IP header, right. Is it its own IP? Generally it is, right. Then check what protocol it is. For example, TCP or UDP. Right. According to this, then pass the subsequent content to the corresponding transport layer protocol. To our transport layer. Then the transport layer checks the port number inside. Destination IP, what the destination, so this destination, whether it matches my own application. Right. Checks if you have, if this port number, that is, if this window is currently open. Right. Just like when you go, but the service window is closed. Right. Then you can't get, right. It's the same print, whether its port number is actually open. There must be a mark, right. To perform the core, if yes, then this data can be handed over, our application, handed to the session, handed to the app, then your software can process it. This is the de-encapsulation process. So two devices. Two computers A and B. They pass through a device in the middle. For example, enabling communication between A and B. It actually goes through a process like this. At A side. At the application. At the application, the data packet is, right. Handed to the transport layer, adds the transport, first segments, adds a header with markers to each. Then passes it to our network layer. At the network layer, you need to fill in your own address. And the address of target B you want to reach. Fill it in at our network layer. Then, the transport layer protocol above it. What protocol is, right? Write it in the header. Then hand it to at the data link, determine the MAC address of A's NIC. And the router's interface. Fill them in the data link layer header. Then, from the physical medium, send the bit stream, send the signal out. Right? From the NIC, send the signal out. Send it out. After it reaches the router's interface, this router interface needs to recognize this message. Right? First, convert the physical signal to digital ones and zeros. A bit stream. Then give it to our data link layer. After the data link layer receives it, it checks the MAC. Is it its own MAC address? Here, it clearly is. Right? It is. So now, it needs to check. This MAC address is its own. Then it decapsulates, looks at the network, and hands it to the, right? The network layer, the target it wants, is actually not its own IP address. Right? It is not its own, it is target B. At this point, needs to do what with this data packet? We call it forward this message out. Forward it out. When forwarding, you need to encapsulate this packet again. Encapsulate it at the network layer from A to B. Then write it again. So this part doesn't actually need to be manipulated. Only certain bits need to be manipulated. Then the MAC address, right? At the data link layer. Here at the data link layer. These network layer packets are handed to the data link layer. Encapsulate again. MAC address. Note that this time, the router's write interface. And the destination MAC is B's MAC address. It will be filled in, if there are several hops in between. It belongs to another device. It is not the direct, for each segment, we say data link layer transmission is hop by hop. Right? Write clearly the MAC and the other side for each segment. Then hand it to the physical layer. Transmit this at this point, B receives it, right? After B receives it, the same D unpack it. See that the IP address is its own. See that the IP address is its own. Then continue to unpack to the find the corresponding, then reassemble. After reassembly, hand it to the session layer. Then hand it to the presentation layer for decoding. Decode, decrypt, and decompress. Right? Then give it to the corresponding application protocol. Then hand it to then display it for you. Show it to you, and that's it. This is our processing procedure during data transmission. How data goes from this computer to that computer. The entire transmission process. That's basically how it is. Okay. That wraps up this lesson. In this lesson, we covered the OSI 7-layer network model for data communication. We also learned the process of data encapsulation and de-encapsulation. Okay. That's all for this lesson.